We're going to talk about things like constraints, we're going to talk about things like foreign keys, and we're going to talk about what the different notions of correctness are. Because it turns out there's different ways for us to determine whether something is correct or not. And neither one of these two approaches is better than the other. They're actually appropriate for very different use cases. You may have heard people say things like, make incorrect states unrepresentable. And this is what you might say is correctness by construction. If the data exists, it must be correct. There must be something that's been checked on that data. There's invalid data, cannot be represented in the system. And therefore, if the data is in the system, it must be valid. And the other approach you can take is you can perform some sort of checking. This is correctness by validation, predicative correctness. There's a couple of different terms you might use, but I'll show you an example in Python that will kind of make sense. Here I have a data class, and in this data class I say, when you're creating an object of this type, you check the value, and if it's negative, you refuse to construct that type. And so if I try and store a negative value here, I cannot because I get an error. Now, obviously, since this is Python, I can do some things that otherwise, I might not be able to do in other languages, like I can change this. So I might need some things like a property to check this again. There's quite a few things that I might need to get this example to work, and there may still be some contortions to force it to store invalid data. But rather than go into the contortions to work around these mechanisms, one thing that I'd like you to think about is, why would you entertain that idea in the first place? Why would it be the case that you're sitting there at 3 a.m. in the morning saying, oh, this check, I want to disable it, I want to get around that check? Because it'll give you some insight into why it is that this sort of constructive correctness is not always what you want. For the predicative correctness, what we could do is we could allow the data class to store anything, including some invalid data. And so here, with a negative value, it stores some invalid data, but we have a predicate to ask, is this data valid? And what you could think is, as part of our analysis step, we could do something like, give me all the objects if the object is valid. And so we might do some additional constructive approach to construct the valid subsets of data, but we don't prevent this from being represented at all. Now, it may seem like you always want to have that constructive correctness. And here's where I want to share with you a debate that I think is oftentimes people talking past each other. You may have heard of things like triggers or constraints or foreign keys, and you may even know that in some large companies, people say don't ever use these tools, don't ever use foreign keys, don't ever use constraints, don't ever use triggers. And there is sometimes a strong hesitation for these approaches. And I think it's often the case that this strong hesitation is born out of problems that people run into when they have databases that are overly restrictive. Think about this. Why might you want to be permissive about storing invalid data? Well, what if the notion of validity changes over time? What if what is considered invalid today is no longer invalid tomorrow? Or what if what is considered invalid tomorrow invalidates data that was collected previously? Well, that's kind of a problem, because what do we do with all the previously collected data? We can't throw it out. If we make it unrepresentable in the system, well, then what do we do with all that data collection, which might have been very time-consuming or it might have been very costly? Similarly, I'm sure everybody in their life has had an experience where you went to some doctor's office, some government office, and they asked you to fill out a form. And as you were filling out the form, you stopped on one section, and you said, this section is completely irrelevant to me, my circumstances in my life. And if it was a form like that, they might have put a little star saying required field, but you just put an N8 there, or you just put a cross out, or you just gave the form back to the person. And they said, okay, no big deal. That happens all the time. Whoever wrote the form didn't really consider the changing circumstances of how people's lives are. Or if there was a field that wasn't really applicable to you, you filled in something that didn't quite fit into that field. Like, for example, if they say, what state do you live in? And you say, well, I'm from Canada. We don't have states. We have provinces. Or they ask what your zip code is, and you come from a place that doesn't have a zip code. You've scribbled something in the column. You found some way around this. However, imagine if that isn't a paper form, but instead is some sort of computer-generated form. And you have a little red asterisk that says you cannot proceed unless you fill in your state, and it has to be from this list of 50 states. And you say, as much as I enjoy being in the United States, there is no Canadian province in this group of 50 states. As much as I enjoy getting whatever service that I'm getting here, I can't give you my zip code. I wish I could, but the place where I live doesn't have zip codes. And if that is a computer form that is overly restrictive, you tend to see that the data quality really starts to degrade as people misuse this form, because then they'll be forced to fill in like single periods because it's not applicable, all sorts of tricks they have to get past the you must fill in this field, or all sorts of tricks they have to fill in fields that are just not applicable to them. You'll probably get a lot of zip codes like 00000 or 12345 or 90210 just so that somebody can proceed. In general, I think what we see is that data collection should be very permissive. Because if you do not allow somebody to fill in the data, they're either going to make your data messier by finding some way around the restriction, or two, they're not going to fill it in at all, or three, they're going to fill it in, the circumstances for what is considered correct will change, and you'll throw away data that you wanted to collect. And so in general, my view is when you're performing the data collection task, you want to be very permissive. You actually want something closer to that correctness via some sort of check, via some sort of validation. You just collect anything that is input, and then later you say, okay, is this valid or not? And where you do some validity checking is you give some feedback, some guidance to the user to say, oh, by the way, you forgot to fill out this portion of the form, just to help them out. But ultimately, maybe it's valuable to let them ascertain whether or not that is really required or not, especially if this is some human augmented process. When you're checking in for a flight at the airport, there's always going to be a human being at that check-in counter who's going to check your data one more time if you're flying internationally, who's going to scan your passport one more time if you're flying internationally. And so maybe you should be a little bit permissive about filling those in because there's always some last step that's checking them. However, if you're overly permissive, then you make analysis very difficult because every single analytical step has to say, give me all the rows that are valid according to such and such condition, and also because what is considered valid changed over time, give me all the rows that are valid as long as they're before this time under this condition and after this time under that condition, and the analysis becomes very, very difficult. And so, on the other end, I believe that data analysis should be very restrictive because when you provide a table to somebody for analytical uses, you want them to be able to write simple, obvious queries that answer their questions. And you do not want them to have to remember all of the rules, some which predate them being at that organization, for what constitutes valid or invalid data. You want to give them a simple, dumb table, and they write simple, dumb queries, and those queries are correct. And I think what this means is you oftentimes want to decouple your data collection from your data analysis. On the data collection side, you want to allow more or less anything that is meaningful or you anticipate should be meaningful, and you want to be very permissive. And then you want to take that data and you want to, via some predicative approach, construct tables that contain data that is only ever correct by construction that allows for simple analysis. I want to talk about how we can make sure that our analytical tables can be enforced to be correct, and this is where I think things like primary keys and foreign keys and constraints are a very valuable thing to use, because largely the analytical result, well, you can always reconstitute it. The analytical result is oftentimes very specific to somebody's use case, whereas data collection is not always specific to somebody's use case. Sometimes you just want to collect the data for the sake of collecting the data, but you don't know what you're going to do with it later. Whereas the analysis can always be, oh, let's collect these portions of the data subject to these criteria to ensure that it's correct so that we can solve one specific problem. And whereas you can think there is one instance of data collection, there can be multiple instances of data analysis. There can be multiple analytical tables that each have their own notion of what is considered correct for that one particular use case. And so, what can I do? Well, simple things that I can do to ensure that my data is correct is I can invalidate rows where a field is null. And so here I have a table which requires that both fields be filled in. Is that something that you want to enforce on data collection? Well, there may be a really important reason why they didn't fill in a field, something that you didn't capture in your modeling. But for analytical use cases, your analysis may be meaningless if a field wasn't filled in, and putting is null, is not null checks all over the place might very much clutter up and leave your queries extremely clumsy. So null checking constraints are a very good idea on your analysis, on the analysis side, on your analytical tables. What else? Well, ensuring that the data is within bounds, within correct bounds, the data, the fields themselves are valid. That's also another good thing to do. There may be a reason why the data was input in a different way. In this case, you might say, well, if this is a table and it contains prices, it's nonsensical for a price to be negative. And so maybe that's something that's worth doing on the collection side. Things which are just outright nonsense will always be nonsense. It will never change. You can never buy something for negative. You can never, a price is a magnitude, right? So you can never have a magnitude that's signed. The magnitude is always an unsigned quantity. So you can say, definitely, that's fine. But even if that's not the case, on the analytical side, you could do something like a check constraint here that checks that the value is always positive. And if this happens to be a tool like Postgres, you can even have more specific or more sophisticated checks. You can have checks that check columns against other columns. So you can say, check that if the category of this data is such and such, then there's a minimum value that is applied that works in conjunction with this other minimum value. So if it's a category A, then the value must be over 100. And if I try and input something that isn't, you can see it is not allowing me to represent that data. Here, one thing you should always remember, though, is remember SQL works on this tuple basis. And so here with these kind of checks, you can look within the tuple. You can check one field against another field. But what you can't do with these kind of checks is you can't say, make sure that this row that I'm inserting is not greater than the greatest of all the rows that already have been inserted. That's where you might require some sort of trigger, because with the simple checks here, they're always checking one tuple and making sure that one tuple is valid, looking at only the tuple itself, not that tuple in the scope of the entire collected data set is valid. And you can think circumstances where you can say, every value after such and such value after the first initial data insert has to always have some condition. It always has to be within 2 standard deviations of the mean, or it has to be lower than some maximum that already exists in the table. It's not an unlikely thing to come up, but you can't express it like this. You have to express it with something like a trigger, which has full table visibility. Another thing you could do is you could say, something for the category. The category has some constrained values. And via things like the Postgres type system, you can express these constraints. You can say this is some sort of categorical data. This is some sort of enumerated data. The category can only be one of 3 things, cat A, cat B, or cat C. Now, note how tricky this would be if you needed to migrate this table. If what is considered valid changes over time, that's going to get kind of tricky. Because if you change these constraints, what do you do with rows that don't meet those constraints? Do you throw them away or not? But if you're not doing this at data collection time, but instead are doing this subject to one analytical use case, well, if the data changes or your knowledge or your model of the data changes, just create another analytical table and create one specific to that one use case. The data collection is going to be permissive to all of the information, as long as that information makes any sense whatsoever. But the analytical use case can be very custom to the thing that you're looking at with the knowledge that you have right now. So you do not need to do a migration on constraints, which is one reason why people don't like to use constraints, because they're very tricky to migrate and they're very expensive to do that kind of after-the-fact modification to. Another thing that you might do is you might discover that as a consequence of wanting to store facts, and as a consequence of those facts potentially leading to anomalies in the data as the data changes. You might want to have an analytical table that is live updated against a real table, and you want to eliminate anomalies, or whatever the case may be, or the original data collection might have potential for anomalies. Well, what you might want to do is split this into 2 tables, and you might want to say, oh, you know what? The categories can be anything that a user input. It's not a static set of 3 possibilities. It's anything that exists in this other table, and so here you have a foreign key constraint. This column is only ever valid if it refers to something that exists in this table. And when you think of things like primary keys and foreign keys, largely what you're thinking of when you think about keys is the linkage between the tables that you have and ensuring that it's not one table that's valid in the context of just that table itself, but multiple tables are valid in the context of all of these tables. And so if an entry exists in one place, it must exist in another place, or vice versa. Now, what becomes kind of tricky here is, what if this minimum value constraint needs to be reintroduced? And if that's the case, then it becomes kind of tricky because, and I'll remove this query for a moment, if you need that minimum value constraint, one of the things is, well, here you can't add a check because the check is no longer going to be able to see, anything but the check can't see anything but the tuple that it's being inserted. So it definitely can't see another table. So what you'll have to do is you'll have to do something like add the minimum value to this table over here. And there generally, other than triggers, there generally are no easy ways to enforce constraints of this form between tables. You'll either have to significantly change the modeling, or you might have to have one more layer of constructive correctness, something like a view, which performs a join, which gives you only the values that are valid. And then you could separate valid and invalid. Bear in mind, here's the thing. Just because the data was invalid, does that mean that you don't capture it? If you have some database, there may be reasons why you want to capture input that somebody tried to perform an action and it was invalid. For example, maybe they tried to use some company-wide currency in order to purchase something, or some points. They tried to use their membership rewards points to buy something. And you want to insert into the table, insert this row that indicates that they wanted to use their membership points in order to purchase some item. But they didn't have enough membership points. Do we want to record that? Maybe you do. Because maybe you want to record that they tried to do something and it failed and it was invalid. So instead of having just one view that's the valid data, you could have two views, the valid data, which you could run reports on, show me all the cases where somebody used their membership points, and the invalid data, show me all the customers who maybe I can convince to spend more to get more membership points, because the last time they tried to use these membership points, there weren't enough. And so there may be many cases where you want to collect data, even if it's invalid, because you can do something with that data. That may represent an audit trail, it may represent something that you can action. But for your analytical use cases, if you want to see who's actually done what, or the average number of membership points, you want to look at only the valid ones. And this pairing of constructive and predicative correctness, of correctness via constraints versus correctness via checking, this is important in the design of your data sources. It is an important thing to balance. And my view is, when you're doing the data collection, try to be very permissive. There are cases where you simply cannot represent something with any sort of meaningfulness, right? In the membership points situation, if they don't even have an account that's active, is that really worth capturing? I don't know that it's worth capturing in your data store, right? Because you could imagine people could fill up your data store with spurious requests where they don't have accounts. So maybe that's just so meaningless, it's not worth capturing at all. You throw it away immediately. But other things might be worth capturing even if they don't represent valid data today. However, when somebody wants to look at that data, you might create some sort of pipeline that takes from the original collection table to an analytical table. That analytical table can be written very custom to the analysis, and as a consequence, it can be guaranteed to be correct via these constraining mechanisms. Other users who use that analytical table can look at the constraints and know that this table is correct. They can say, this only has positive value, so I don't have to check for that myself. I don't have to make my queries more complex. Or, oftentimes the case, it is not uncommon for the institutional knowledge of how a table was constructed and where the data from that table comes from gets lost. The data pipeline pieces may not be that visible. And if you encode the correctness of the table in the table description itself, in the table layout itself, somebody doesn't have to go dig up the pipeline and say, did you correctly exclude invalid data? Because they can look at how the table was structured and they can say, this table by definition excludes invalid data. It is impossible for it to contain data that doesn't meet these constraints, and thus my analytical queries can be more straightforward and much simpler.